Okay, picture this. You're just floating out there in the deep, silent calm of space. It's peaceful. But then you feel something, a tiny pull. At first, it's gentle, but it's getting stronger, and it's getting stronger fast, pulling you toward one of the biggest mysteries in the entire universe. You're about to take a one-way trip into a black hole.
So what would that even be like? I mean, what would you actually see? What would you feel? And would it all be over in an instant, or would it be something much, much weirder? Well, let's find out. We're going to take that journey based on everything we currently understand about physics.
All right, that little tug is not so little anymore. It's a powerful, undeniable force. You're picking up speed, and right up ahead, you see it. And it's not a star, it's not a planet. It's just nothing. A void. Up ahead, you see this perfect circle of pure, absolute black, just hanging there against the backdrop of the stars. It doesn't glow, it doesn't shine, it just eats light. This isn't some empty spot in space. It's an object with so much mass, so much density, that it's actually bending the fabric of reality around itself. And that's really the key, right? A black hole is just a ton of matter crammed into such a tiny space that its gravitational pull is off the charts. The escape velocity, the speed you'd need to get away, is faster than the speed of light. And since nothing can go faster than light, once you're in for good. But before you get to the blackness, you have to survive this, the accretion disk. Think of it as a glowing cosmic hurricane. It's a massive, blindingly bright ring of gas and dust, spinning at nearly the speed of light and heated to millions of degrees by sheer friction. Now, for our trip, let's just pretend you have a magical shield that protects you from all that lethal heat and radiation. You're gonna need it. As you get closer, this is where reality really starts to get weird. The black hole's gravity is so intense, it's literally warping space-time, acting like a giant, distorted lens. You'd see stars get stretched out into these long, bizarre streaks of light. The whole universe would look like it's being folded in on itself. And get this, the effect is so extreme, you could actually see the back of your own head, because the light from behind you is wrapping all the way around the black hole and coming back to your eyes. Insane, right? You're getting really close now, moving toward an invisible line in space. But this line is absolute. This is the moment your story and the story of the rest of the universe go their separate ways forever. They call this the event horizon. The best way to think about it is like the edge of a cosmic waterfall. Before you go over the edge, you could, in theory, fire up your rockets and escape. But the second you cross that line, you've gone over the falls. There is no amount of power in the entire universe that could pull you back out. It is the point of no return. And here's where things get completely mind-bending, thanks to Einstein's relativity. For you, as you fall in, time feels totally normal. Tick-tock. You cross the event horizon without any drama at all. But for someone watching you from a safe distance, whoa. They would see you start to slow down, and slow down, and slow down, as if you're moving through molasses. They would watch as you got dimmer and redder, seeming to freeze right at the edge for an eternity, until you just faded away. Two completely different realities from the exact same event. So what actually happens to you once you cross that line? Well, believe it or not, it completely depends on what kind of black hole you fell into, because they are not all the same. And the difference is, well, it's the difference between one kind of death and a very, very different kind. See, with a smaller, stellar mass black hole, one that formed from a dying star, the curve of gravity is incredibly steep. The tidal forces, meaning the difference in the gravitational pull on your head versus your feet, are so huge you'd be torn apart before you even got to the event horizon. But if you fall into a supermassive black hole, like the one at the center of our galaxy, its event horizon is enormous. It's so far from the center that the gravity is much gentler at the edge. You could actually drift right across it without feeling a thing. But that peaceful crossing, it's just a temporary pass. Because whether it happens before you cross the horizon or long after, every journey into a black hole ends with this same horrifying process. Scientists have a name for this, and it's surprisingly descriptive. They call it spaghettification. The part of your body that's closer to the black hole's center gets pulled exponentially harder than the part that's farther away. This difference in force starts to stretch you until you're pulled into a long, thin strand of matter like a piece of spaghetti. Eventually, you're not even you anymore. You're just a stream of individual atoms flowing towards the center. So that stream of atoms that used to be you is now racing toward the center. And this is where the journey goes from being just terrifying to being completely unknowable. You're entering a place where our understanding of the universe, our science, just stops. At the very heart of the black hole is a concept we call the singularity.
It's not really a place so much as a moment in time. It's a point where all that matter is crushed down to infinite density and gravity becomes infinitely strong. All of our rules, Einstein's theory of relativity, quantum mechanics, all of it, they just don't work here. The math breaks. We literally have no science to describe what happens next.
Okay, so what about that classic sci-fi idea? That maybe this isn't the end. Maybe a black hole is actually a portal, a wormhole to another place or another universe. The short answer from science is probably not. I mean, while the math of general relativity could allow for these kinds of bridges in space-time to exist, we have absolutely zero evidence that they're real. And frankly, even if they were, a stream of spaghettified atoms isn't really in any shape to be traveling anywhere. I think this quote really nails it. Falling into a black hole isn't just about dying. It's about taking a journey past the edge of physics itself. It's where time and space break and reality as we know it completely unravels. So why do we even care about all this? Because black holes are not science fiction. They are very, very real. In fact, there's a supermassive one right at the center of our own Milky Way galaxy. By studying these bizarre, extreme objects, we are pushing the absolute limits of our understanding of gravity, of time, and of the fundamental fabric of our universe. So that kind of leaves us with one last thought. The next time you look up at the night sky, at all those beautiful stars, just remember what else is out there. Hiding in the dark voids are these cosmic monsters, so powerful they don't just swallow light, they swallow the very rules of reality itself. It's a pretty humbling reminder of the incredible and sometimes terrifying universe that we all get to be a part of.